This video we're going to look at velocity time graphs. Now in the previous video we looked at displacement time graphs. Velocity time graphs are a little bit different. So in a velocity time graph you have, instead of displacement, you've got velocity on the vertical axis, and on the horizontal you have got time. Now there's two big differences. First of all, a horizontal line in a velocity time graph represents a constant velocity. So constant velocity is a horizontal line, and your gradient at this time gives you your acceleration, because your gradient gives you your rate of change of velocity with respect to time, which is, and change of velocity with respect to time is gradient. So that's where that comes from. And one additional thing which is very good for a velocity time graph is the area onto this graph. So if you imagine I found this area of this triangle, this area of this rectangle, this area of this trapezium would be, and this area of this triangle, added them all up, that would be the total distance traveled by this body, whatever this body happened to be. So the area onto the graph gives you your distance that you have traveled. Okay, we're going to jump in and look at this example and see how we get on with it. Okay, this question says calculate the acceleration and distance traveled during each phase of motion shown below. So you can see I've labeled my the points in this graph as being 0, A, B, C, and D, so that we can look at each phase. So we're going to look from O to A, what's happening first of all. So for O to A, we'll just say like acceleration, just say ACC is equal to, and it's your gradient. So your vertical change is 15 over 10, which works out to be 1.5 meters per second squared. And I'll talk at the end of another wee way we could write the units here. And your distance, the distance, it's just a triangle. So it's a half times the base. The base of this triangle is 10. Height of this triangle is 15. And if you do that on your calculator, whatever way you want to do it, you get 75, and it's going to be meters. From A to B, so from A to B, this will be horizontal distance, horizontal line. Horizontal line, remember, means a constant speed. So his velocity, or speed or velocity. So his velocity is constant at 15 here, or sorry, the acceleration, that would be a constant velocity, that's absolutely right. But if your velocity is constant at 15, that means you're not accelerating. That means your acceleration is equal to 0 meters per second squared. The distance then for this wee section is just a rectangle. The base of the rectangle is from 10 to 20, so just 10. Height of the rectangle is 15, so the distance is 150 meters. Okay, from B to C, again, acceleration is dead easy. Acceleration is just your gradient. So the gradient, my vertical change is from 15 to 25, so it's going to be 10. And my horizontal change is from 20 to 30, which is just going to be 10 as well. So that's just going to be 1 meter per second squared. The distance is a wee bit trickier. So for the distance, this shape here, this is the shape I'm talking about. This shape is a trapezium. So it's going to be a half brackets A plus B times H. So the parallel sides are the A plus B. So one of the parallel sides is 15. One of the other parallel sides would be 25. And then the perpendicular distance between them is 10. So that's going to be a half times 15 plus 25 would be 40. Half times 40 would be 20 times 10 would give me 200. So 200 meters. Okay, from C to D, first of all, what's happening here for this? Have we look at this? I am up at a speed of 25 and I'm getting down to a speed of 0. So to get down, I have to decelerate, and deceleration is negative acceleration. So I should get a negative answer here. So my vertical change is minus 25, and that happens in 20 seconds. So that's going to be minus 1.25 meters per second squared. And my distance, it's just a triangle. So it's a half times the base of that triangle. Base of that triangle is 20. Height of that triangle is 25, which is going to be 250 meters. And that's that example done. This example says an object accelerates from 5 meters per second to 10 meters per second in 2 seconds. It then uniformly decelerates to rest over 4 seconds. Draw a VT graph, so that's a velocity time graph, showing this journey and determine the total distance traveled. Okay, first thing before I get started, uniform deceleration just means constant deceleration. And so that's all they're talking about here. Okay, I'm going to pause the video and I'm going to draw this graph and then I'll talk a wee bit about it. Okay, so we've got our velocity time graph drawn. So he started at 5 meters per second and accelerated up to 10 meters per second, and he did that in 2 seconds. It then says it uniformly decelerates to rest. So from the speed of 10, it goes down to 0, rest to 0, and it does that in 4 seconds. So 2 plus a 4 gives you 6. So that's how we've arrived at our velocity time graph. It says what we're to do is determine the total distance traveled. So I've split my velocity time graph into 2 bits. I'm going to find this area. This is area 1. And I'll find this area. This is area 2. And my total distance is going to be area 1 plus area 2. So to find area 1, this shape here that I'm tracing out is a trapezium. So you've got a parallel side here, which is going to be height 5 or length 5, and a parallel side here, which is length 10. And also the perpendicular to the distance between them, which is 2. So I'm just going to reuse my trapezium formula, half a plus b, so 5 plus 10, times the perpendicular distance between them, which is 2. Do that out, so it's a half times 15 times 2, it's just going to be 15, and it's going to be meters. My area 2 is just a triangle. It's got a base here of 4, it's got a height of 10, so area is a half times 4 times 10. Half times 4 is 2, times 10 gives you 20 meters. And your total distance then is just going to be 15 plus 20, which is 25 meters. And that is that example done. Our next example says a body accelerates uniformly from rest for 4 seconds at 2 meters per second squared. So 2 meters per second squared is acceleration. It then continues at this speed for 6 seconds before decelerating back to rest at 4 meters per second squared. Draw a BT graph showing this journey and determine the overall distance traveled. Okay, I'll pause the video and draw the BT graph and then explain where I've got it from. Okay, first of all, here's my velocity time graph. So I have accelerated from rest at for 4 seconds at 2 meters per second squared. So that means in every 2 meters per second squared, let's just look at that breakdown of those units. 2 meters per second squared means you're changing your speed at 2 meters per second. So that means in each second your speed is increasing, or your velocity is increasing by 2 meters per second. So in 4 seconds, 2 times 4 gives you 8 meters per second. So that's how we've got from 0 over here up to 8 meters per second in 4 seconds. It says then it then continues at the speed for 6 seconds. So from 4 plus 6 seconds takes you up to 10 seconds, and then before decelerating back to rest at 4 meters per second squared. So I'm at 8, and I'm going to decrease my speed at 4 meters per second. So let's just write that out again. 4 meters per second squared means 4 meters per second. So if I'm at 8, I'll just say 8 divided by 4 gives me 2 seconds. So that's how I've got from 10 to 12. Okay, a lot of people aren't going to like that, so I'm going to do that out a different way, showing a wee bit more, of an explanation really. But that's really what I'm doing in my head to work all this out, and then I'd calculate the distance time graph. So pause the video and write out a better explanation for this really. Okay, so there's the explanation of that. I'll written out a wee bit better. So initial stage, so the acceleration in the initial stage was 2 meters per second squared, which means the speed goes up 2 meters per second. So in 4 seconds it goes up 2 times 4, so it goes up 8 meters per second. In the final stage, the deceleration is 4 meters per second squared, so that means the speed goes down 4 meters per second, so it goes down 8 meters per second in 2 seconds. So how you've got that is just 4 times the 2, which gives you the 8 meters per second that it decreases by. The last part of this question asks you to find the overall distance traveled. So we'll squeeze this in and we'll just say the distance. And this whole shape here is a trapezium. So it's got a parallel side and a parallel side and a perpendicular distance between them. So the distance is a half times one of my parallel sides is 12, that was a big one, and the smaller one is 6. The perpendicular distance between them is 8. So if you work that out on your calculator, you will get 36 meters. Okay, you can see in this example I've gone ahead and drawn out the velocity time graph. The question says a body travels with constant velocity v for 6 seconds. So you can see I've started at velocity v, and it goes horizontal line, constant velocity, for 6 seconds before decelerating down to 3 meters per second, and it does that in 2 seconds. So if it was at 6, the time is now going to be 8. And if the total distance traveled during the motion is 101, find the value of v. So I've called this A1 and A2, and we're just going to say the total distance is equal to A1 plus A2, because remember that distance traveled is the area under the velocity time graph, and we're going to sub in what we know. So we're going to look at A1, calculate what it is. A1 is just a rectangle. Its base is 6, its height is v, so A1 equals 6v. And then A2 is a wee bit trickier. It's a trapezium. So half times the sum of the parallel sides times the perpendicular distance between them. This parallel side here is v, and this smaller one here is just 3, so it's v plus 3, and the perpendicular distance between them is the difference between 6 and 8, I should say, which is 2. So if you do that out, you're just going to get v plus 3. We also know our total distance was 101, so 101 is equal to 6v plus v plus 3, which means 101 is equal to 7v plus 3. Take the 3 across to the other side, you'll have 98 is equal to 7v, and then a wee bit of working out, you're going to get your v is equal to 14 meters per second, and that's it. Okay, that is the end of this video.